So today is 2020, some 430 years ago, 1590, a 26-year-old man, Galileo, drove two spears, heavy and light, from the leaning tower of a building located at the University of Pisa, where he was actually a math professor, to collect some data to understand the behavior of falling body. Yesterday I did the exact same thing. I went to the rooftop of my apartment building. My apartment building is 80-meter tall. What I used yesterday, I did not have my calculator with me. I used acceleration due to gravity, negative 10 meter per second square. Instead of negative 9.8 meter per second square, I use negative 10 meter per second square. And I collected some data to draw the graph, to draw the dt, vt and at graph, and that's what I will present to you right now. So I went to the rooftop of my building, and it is 80 meter tall, and this is the ground, and I drop a ball, and I saw it start falling. The ball was in free fall. I was imagining taking a picture of the ball. If I do take a picture of the ball, how would I see it on the picture? So let's say the dot represents the ball at the first second, at the 0 second, in fact, I'll see a dot on the picture. At the end of 1 second, the ball location would be right here. At the end of 2 seconds, the ball location would be right here. At the end of 3 seconds, the ball location would be here. At the end of 4 seconds, I'll see the ball at the ground. What do you notice? You notice the distance traveled by ball are not the same. The ball travels more and more distance over time. Small distance at the end of 1 second, a bigger distance at the end of 2 seconds, even bigger at the end of 3 seconds, a huge distance at the end of 4 seconds. Why? Galileo tried to kind of understand it mathematically. He had access to the math invented by Brahmagupta 700 in India and Al-Khwarizmi in Baghdad 900. The second degree polynomial, sometimes called as quadratic, was invented by Brahmagupta in India and proved by Al-Khwarizmi in Baghdad. So he realized that this is actually a quadratic, and he called it d is equal to half gt square. Okay, so we understand the relationship, we understand the behavior of this dot. Okay, now the second thing we want to understand is the velocity. We know that object is speeding up as it falls. Okay, first second it falls. At the first second, the velocity is negative 10, second negative 20, third second negative 30, fourth second negative 40. We call it the object is speeding up every second as it falls. Okay, we understand that. Now let's talk about the another properties of free fall: acceleration. Acceleration, while the displacement is quadratic and the velocity of this falling body is linear, acceleration is linear constant, 9.8, negative 9.8 meter per second every second. Today you're gonna say negative 10. Okay, we understand it. Good. Now I'm gonna show you the table, the data I collected yesterday.